The chair now recognizes Mr. Gonzalez for 5 minutes.
Thank you, Madam Chair. Thank you, witnesses, for being here today. First, want to use this time to recognize the University of Akron's College of Polymer Science and Polymer Engineering, which is recognized as being one of the world's best in the polymer sciences. University also does great work getting young students excited about the polymer sciences through their Akron Global Polymer Academy, which provides opportunities for teachers and students of all ages to experience the world of polymers by organizing in-school visits and field trips to the university's research facilities. They're doing a fantastic job. Polymer research and development has been huge in Northeast Ohio, where I'm from, for my entire life and before it, and so we're proud of that. I want to take my time to really just understand this a little bit better, frankly. And my first question will be to Mr. Bovin. I'll probably stay with you if that's okay. I first want to understand the interplay between mechanical and chemical in the constant context of the circular economy. It strikes me as I read your testimony that chemical is probably how we get there ultimately. I'm sure there's a role, obviously a role for mechanical, but can you just kind of walk me through that for a second?
Yeah, sure. Thank you for the question. So when you look at there is a relationship between mechanical and chemical recycling in the sense that we would suggest that if it can be mechanically recycled, it should be. It should be because it has a lower carbon footprint. It's not as energy intensive, and it can be deployed locally, right? You can do mechanical recycling at a very local level very effectively. The challenge with mechanical recycling has always been finding end markets because you'll have some polymer degradation. Products that cannot be introduced into the mechanical recycling system effectively are the products that should go into chemical recycling. Because at that route, you can address the contamination issues that come. And in fact, when you talk about MRFs today, on average, about 25 to 30% of the material going into a MRF is actually rejected because it's too highly contaminated to be processed. You can feed that into a chemical recycling process to then recycle the product.
Thank you. And then my second question, when it comes to chemical recycling, I'm going to score these 1, 5, and 10. So if 1 is sort of we understand what needs to happen, but we haven't really started developing. 5 is our tech is viable, but we need to define business models to get it deployed more in the market. And then 10 is we understand the tech, we understand the business model, we just need to deploy and scale. Where are we on chemical manufacturing?
I would put us at a 5, quite frankly.
Okay.
When we're talking about chemical manufacturing, we're talking about mature technologies like gasification, pyrolysis. They've been around for a long time. They have not been used widely for the purpose of recycling plastic. And so we're talking about putting a value chain together and different partners together to aggregate the plastic to get it to a chemical recycling facility. From there, you turn it into an intermediate, and then you have to integrate it into the current petrochemical industry.
Okay.
So we have to work on the business model side.
Okay, so it's a combination of business model. Once we get there, then we can scale it. My last one, and I kind of hate to go here, but these paper straws, they are my pet peeve. I took my son the other day to get a milkshake. He's 1 year old. We do this on Saturdays. Paper straw shows up. The thing disintegrates before we're a third of the way through. He's also throwing whipped cream at my face. So, you know, all kinds of things going on there. I personally despise them. On top of that, only 0.025% of plastic that's flowing into the ocean is straws, plastic straws. They also require more energy to use or to manufacture than plastics. So I kind of want to just have you give me some hope that maybe Dow is working on either new technologies, new bioplastics that are more efficient and better for the environment, or that we're making progress on the sortability. Because my understanding is the reason why it's hard to recycle plastic straws is because it's hard to sort them. So give me some hope, please.
Yeah, we should take hope. There is hope, and I say that because plastic pollution is now widely accepted across the world. And you see collaboration happening across the value chain that hasn't happened, at least in my 22 years in the plastic industry. You see industry partners coming together, making investments like the Alliance to End Plastic Waste, where over $1 billion has been committed to fund solutions to drive the ending of plastic waste. Now, is $1 billion enough? I know $1 billion is a great start, and we expect it to continue to grow. When you talk about biodegradability or bio-based plastics. Those are two very different things. We think the focus needs to be on investing in infrastructure to recover the plastic and retain its value. That's where we're spending a majority of our time, and we don't want to get distracted with other things that aren't going to have a meaningful impact.
Okay, thank you, and I yield back.